Hi, thank you all. I'm really glad to be here. Also, I came alone, so if you take pictures, share it with me so I can show it to my mom. Well, I'm going to talk a little bit about how we handle an incident in Kubernetes in Argentina. I don't know if you are used to work with clouds environment, especially with Kubernetes environment. It really changed a lot when you need to face these kind of things in a corporate environment and in a startup environment, especially because of the governance. Most companies and fasten their time to market so much that they forget about doing a lot of stuff regarding security and preparation. And these kind of implementations, you are going to see that leaves a lot of ground for the attackers to do mostly whatever they want, especially if we trust in automated detection mechanisms like the one that are not tailored for our particular purposes. So, well, this is me, and let's start. We got called by a client with this message. This was what they were seeing in their website. As you can see here, there is this is a S3 bucket public static web hosting. So they were using the cloud, using S3 buckets to publish their website. And suddenly their website wasn't there anymore and they were seeing this. What this means is that the content inside the S3 bucket, inside the AWS tenant, was encrypted with a k8s key, and they didn't have the authorization to view that content. And they didn't know why. So they called us to do the response. We started to review the logs. If you're aware a little bit about how AWS work, and more or less every cloud tenant works in the same way. Everything is an API. So each request that we do against the cloud environment is based on an API communication that is logged in different ways. In AWS, that's done through CloudTrail. CloudTrail is the AWS service that is used to log those API calls. So we asked them for those logs in order to understand which was the change that make the page looks in that way, encrypted, right? So they told us that they didn't have the logs. As usual in startups, they weren't prepared for that. But luckily for us, we are used to deal with those situations. And CloudTrail is something that you need to enable, but under the hood, you can retrieve those logs without having them enabled if you are accessing them programmatically. Within the CloudTrail logs, we can see a lot of stuff. We can see who is accessing the S3 bucket itself, which users are being used within the cloud tenant, which KMS key, which encryption key was created or not. But what we cannot see is what's happening within the objects inside the S3 bucket, because those objects are in another domain within the scope of how AWS handles that login. That it's called event data. And it's not enabled by default because it's really expensive. Imagine if you have to log every access key, every access call to each object that is publicly exposed. So they don't give you that. Even though we started to do the research and we started to see something like this. This is how in the AWS console you can see the API calls. The problem with this is that it's not easily to analyze because you cannot do much queries. The way of downloading them is really hard. It's a CSV. It's not practical at all. So we develop a small tool to retrieve those programmatically and to get to do some grep and AWAK and that stuff that we like to do in order to analyze logs. This is a small example of how we do that stuff. Basically, can you see it well? What I'm doing there is executing a script that's called dredge that allows me to authenticate against AWS using an authentication profile and a region. I can select a specific date, and with that, I can get all the log of event history. So what we were seeing in the AWS console that's not practical at all, we can retrieve that in a text format and grepping and getting whatever information we need in order to analyze that incident. We can dump this to a file and continue the analyze in the way we like. With that research, this is an example of a CloudTrail log. If you haven't seen this, you have a lot of data. It's like a really, really rich log. You can get user agents, source IPs. There is a lot of stuff that you can get over this. And if you are not familiar with AWS incident response, this is the bread and butter to handle whatever incident is happening there. What caught our attention was this. This is a specific API call that is get authorization token. This is a way that AWS allows you to authenticate to an ECR registry. An ECR registry is a place where you can securely store your Docker images for your code to run. So you have your application, you containerize that inside a Docker image, and you can save this in an ECR registry for your application to work. What we saw here was that a user that was not supposed to authenticate against the ECR registry was doing so, and we didn't know why. The issue with this was that the source IP address was from inside, it was an AWS IP, so it was inside the AWS tenant from where we were getting this API call. But as it was weird, we started to investigate a little more. The ECR requires you permissions in order to be able to do that authentication. So with what we knew so far was the attacker was able to encrypt an S3 bucket and was able to authenticate to this ECR to execute these commands and being able to push images to this secure place where the company was storing their data. There are different ways how you can handle authentication in AWS and in Kubernetes. The most weak one is using access keys and secret access keys that are credentials that does not expire and allows you access to the AWS tenant. The other way you can authenticate against AWS is using roles. Roles are another type of entity that has a session token that will expire. With Kubernetes inside AWS, you can associate that role to what's called a role in Kubernetes or a service account. So you can create a match between what's inside the IAM authentication and the airbag processes within Kubernetes with the IAM access within AWS. This is really, really dangerous because if you don't segment that, maybe a container, a Docker container running within your Kubernetes tenant can have the same access as the Kubernetes cluster on its own. And that can be really, really disastrous because you don't have any segmentation at all. For you that don't know, Kubernetes is an orchestration platform. It's like having a cloud provider inside our cloud provider. It allows us to allocate different kinds of resources within our same resources that we have in our cloud provider. For example, if I have 2 servers and 4 applications, Kubernetes will allocate them in the most efficient way. And if for any reason I need more resources, Kubernetes will interact with my AWS tenant in order to create those servers. So if I have 2 servers and I need one more, Kubernetes is able to execute that API call. That's why it's really dangerous if an attacker is able to get the access to the same level of permissions that the Kubernetes cluster have, because by default, the Kubernetes cluster will need to interact with the most valuable resources inside the, the cloud tenant. Especially if you're running infrastructure as code, most companies that run Terraform, CloudFormation, and that stuff used to run those services within the Kubernetes cluster. Using infrastructure as code, what you can do is like, for example, you can create users programmatically and in an automated way. That's nice for time to market, but it's really bad for security, especially if you are not hardening the IAM users in the way that it should be done. Also, Kubernetes, as I told you, is another cloud provider inside a cloud provider. So it has its own kind of logs. You have API server logs that are the same as CloudTrail, but in Kubernetes are all the requests that are executed against the Kubernetes API. We can get those from this log. We have audit log that is getting everything that's happening, all the changes and modifications. We have authenticator. The authenticator log is the one that will let us know who was executing which API call from and from where. For example, the one that is in the lower side is really small, but what it says is this AWS role has authenticated with this Kubernetes role and is able to execute API calls within the Kubernetes. And it's really difficult to, it's not usual that companies are tracking those logs, and that those are not usually correlated with the CloudTrail logs. And then we have the control manager and the scheduler that are those are events that we can handle in order to understand what's going on within the infrastructure, within the Kubernetes cluster. The most important ones and the two that I highlighted, and in AWS, you can get those within the AWS console. You can enable them and you can push those to a solution that's called CloudWatch that will allow you to get a log like this in JSON format and in a nice way. The issue with this is that most companies don't have those enabled and are not tracking what's going on within their own cluster. Especially if they don't know that they are hacked. So this is the way that a container image is processed. If you can see here, we have the source artifact when we build, when we code, and when we create the Docker image with the application that we are going to run. Then we harden the image, we test that, and we deploy that in an ECR container. So what in ECR registry, what the attacker was able to do was able to skip all this process and jump directly to the ECR registry, uploading their own Docker image. This is an example of the architecture for you to get an idea. And you can see the K is the Kubernetes cluster. It was protected with a load balancer and a web application firewall, but that didn't matter. It's interacting with servers, and also it can interact with Amazon S3 for hosting the web page. All the logs are being shipped to CloudWatch, and they had enabled AWS Guard Duty, that is a automated threat detection tool that is used really used is really used in AWS environments, because it's not only monitoring with what's going on within AWS, but also monitors what's going on within the Kubernetes cluster inside AWS. The issue is that at this point, we didn't have any alert. We got notified about the incident because they have a denial of service, but there was no alert for us to understand what was going on. So we need to do this analysis. In order to the response, we identify the IAM user that was executing the API calls that I told you before, that was creating k8s keys, that was encrypting S3 buckets, that was interacting with the ECR repo. And we also created another script to automate the process of response. So we were able to respond this in the most quick way. If you can see there, what we do here is, again, we authenticate against AWS, and we use the tool of incident response that it allows us to delete the IAM user. We created this script because deleting an IAM user is not something trivial within AWS, especially if the user has different properties. First, you need to remove the access keys for that the user might have to interact programmatically with the AWS tenant. Then you need to remove the console access, and then you can remove the user. If you don't do those previous steps, the API call to remove the IAM user is going to fail, and you are going to struggle debugging why it failed, and that's not practical when you are handling an incident. After doing so, we needed to do a little bit more of research, so we did a quick filtering to understand which well, what we wanted to understand was which API calls were, well, it seems not working. Okay, well, what we did here was to understand from the whole from all the logs that we had, that again, we had those in raw because they didn't have them enabled. They didn't have a SIM, nothing. So we parse everything in a raw format to understand better what was the context. Well, I cannot play this. From there, we got a lot of different IPs. Some of them were normal, were part of the normal behavior of the tenant, and some of them not. So we created and started to block those IPs to further advance with the contention. How was the impact? Well, what we found within the ECR registry and within the Docker image that I told you that the attacker was able to leverage was a cloud ransomware. Ransomware against S3 buckets work in a fancy way because they don't need to be within your AWS tenant to launch the attack. They only need access to the access key that I was mentioning you before. Basically, what the attacker does is to create a k8s key that is an encryption key and attach to that k8s key a policy. The thing with that policy is that regulates who can access that key and who's not. If I allow a user and only one user to access that access key, not even the more admin of the admins would be able to remove that key. It's only that user is able. So what they do is that they create an IAM user, they assign that policy to that IAM user, and they remove the user for you to don't get access anymore to that key, and you can recover that key. So the objects that are encrypted with that encryption key would not be retrieved even if you are root in the tenant, and that's awful. So that's why it's important for us to respond quick to this, to quickly respond to these kind of events. Then before that, they download the object if they want, and then they upload the ransom note. There is another version of this kind of attack when they simply delete all the objects. But if you have some insight of what's going on and you see that all the object has been deleted, you are not going to pay the ransom. At the end of the day, they want you to pay that for the process, right? The nice thing is that API calls against S3 buckets are really slow. So it's not something that is really, it's not something fast for them to encrypt all your S3 buckets. But as we can see, even one object can be really damageful. and we didn't have security detection. Besides, we have that implemented. As I told you, there is a tool that's called Garduti that is an automated threat and response tool. What it does is like it correlates a lot of logs within AWS in order and merge that with some kind of intelligence, some intelligence to generate detection rules based on the behaviors within your tenant. The issue with this is that it learns from what you have and is not tailored for your custom behavior of your tenant. So if you have bad practices, you are going to get a lot of false positives. And also it assumes a lot of things that like trusty, for example, if the API calls are being generated within your AWS tenant. We didn't get an alert in here because the Docker image with the ransomware was running within the Kubernetes cluster within our AWS tenant. So the origin was trusty. It was our own IPs, our own infrastructure. It was running from inside ourselves. That's why we didn't get any detection with this tool. So I hope it works. Let's make a quick review of how the incident worked. What I'm going to do now is to replicate the API calls that attacker did after getting access to elevate those privileges and to end up deploying the Docker image within the Kubernetes cluster. What is doing here is retrieving AWS credentials from an static file. The attacker did this within a pod that's a Docker image running within the Kubernetes cluster. They were using these access keys for the web page to interact with the S3 bucket. Now, what they are doing is executing a get caller identity. This is like a who am I in AWS. It lets the attacker know what user they are using and against which AWS tenant. As you can see, it says, this is the account number, and this is your ARN. The user was Terraform, so it was an infrastructure as code user. Then what they did was check if the user has a login profile. A login profile is what the user can use to connect with the web browser to AWS, and they didn't have. So they created one. The funny thing is that this is a normal behavior of a lateral movement within AWS, and it was not detected at all. And that's scary, because if you have somebody with a Terraform user that is prepared to be an automation and an infrastructure as code tool, they shouldn't be having a login profile and connecting with the console. So with that, they have created the login profile. So at this point, the attacker was able not only the attacker knew that he has an overprivileged user, and he was able to connect to the web console using it. This is how the AWS console looks like. As you can see, in order to authenticate, you need to have the account number that they got from the STS get caller identity, the IAM username, and the password that he already created. This is also really dangerous, because if you have a user that doesn't have a login profile, doesn't have a password, when you create the login profile, you can set that password. So it's really insecure. Then they started with an enumeration process. The enumeration with AWS basically starts to understand what can I do, right? They started to enumerate S3 buckets, IAM users, k8s clusters, ECR repos. This was done in an automated way. There are plenty of tools to automate this kind of behaviors. In this example, you can see that with one command, they can know that there is an ECR cluster within their environment. And again, as these API calls are like super specific, they don't trigger any alert on their own. You don't have an alert because you have a described ECR repository. It's not something that is common as a detection use case. And after that, they executed the commands to get the login. As you can see, you need to use the get login. This is the API call that I showed before. You have to get the login password and the region and the profile. And with this, you can execute commands against the Kubernetes cluster as if you were an admin. Why this is very dangerous? Because when you don't have a proper governance applied to the Kubernetes tenant, you can do things like storing access keys and secret access keys inside the Docker images or inside the Kubernetes secret that is a feature of the Kubernetes cluster that allows you to store those kind of secrets, but they are not encrypted by default. They are base 64 encode. So if you're able to enumerate all the secrets within a Kubernetes cluster, you can get all the passwords that are being stored as environment variables. This is a demo on how they got access to the Kubernetes cluster. Again, they are listing the cluster to understand what if they have a cluster running within the environment. Again, these API calls don't trigger alerts by default. So for us as incident responders after this, we need to understand these behaviors in order to create better detection rules for ourselves. After that, they update the kubeconfig. The kubeconfig is a file that handles the authentication with AWS and against Kubernetes. This is what I was telling you before regarding the roles. What this does is aligns my AWS role with the Kubernetes role. So now I can execute API calls with kubectl against the Kubernetes cluster. For example, now I'm applying a Docker image that's within a Kubernetes manifest. If I show you the manifest, what it has is like some description and metadata, but basically what it's doing is it's applying a Docker image from this ECR. So what I'm going to see from the Kubernetes perspective is, okay, I'm trying to install new software, but from a trusted party, right? Um, One thing that companies used to do in order to harden themselves is to implement this trust control that you can only install from the ECR. But if I have compromised and I have poisoned your ECR, that won't do anything. Okay, so this is how the incident happened. What I'm going to show you now, and to finish the presentation, and especially to have some minutes for question and answer, is a short demo on how the S3 ransomware works. Basically, what we have here is a Python script that what it does is it creates the policy. As you can see here, the policy has a principal, a owner, that is an IAM user. That's the user that the attacker had compromised. What it does is interacts with the objects within S3, get all the objects and replace them with a new version of the object that has been compromised. And then it proceeds to delete the user. So I broke it. So let's run it quickly. Here I have for you an image. I hope it don't fail. This is an image from a mountain in Argentina. As you can see, I can retrieve this from my S3 bucket created for this demo. if I run the ransomware, it would start. It's going to create the KMS key. It's going to download the object. This is, as you can see, it's not fast. Even if you apply multi-threading, the downloading is really low. Especially because I'm over 4G, right? But wait for it. This is the issue with the live demos. It's like, but I cannot record it because I want to show you the encryption part. But well, if you want, maybe we can do the Q&A in the meanwhile it finishes.
The problem of the live. Thank you again, Santiago. Now is the most awaited moment about the Q&A phase. So you have the microphone in the middle of the room. So want to make a question? Please do it by the microphone in the center of the room.
Well,
without the question, you can go ahead maybe with the example.
Could I just ask a quick question?
Yes, of course.
So I can assume this is not like a normal website, like an index.html. This web application that was encrypted, which basically stopped the business of the startup.
Yeah, it didn't stop the business of the startup because it wasn't the application, it was only the web page, because they were hosting only the static web page over there. The business logic behind the startup was not compromised, but it was their how they show themselves to the world, right? It's and at the same time, it allows them to understand that they were compromised within. The attacker could have done a lot of different things. They could have compromised other parts of the infrastructure that could have impacted the business, especially if they were able to access databases or other S3 buckets that they use to store critical information or maybe client information. Luckily for them, the account that they were using, they were applying a strategy that's called multi-account strategy. So they were segmenting, and the business logic was in a different tenant than the web application. And that's why the attacker wasn't able to move to that other part of the business. Is that okay? Thank you for the question.
We have time for one more question. If someone else want to do it. Otherwise,
can I show you the picture again? And that's the encrypted picture. And if I go to the bucket, now what I can see here is the ransom note that was uploaded with the script. And in the folder, I have the image that was stored in the repo. Okay, that will be all.
Thank you again, Santiago. We have no more questions, so let me to thank you again, and thank you for your speech, really interesting speech, and help me to thank you, Santiago, with a big applause, please. Thank you.